Hello, and welcome to Creations of Our World, the podcast where we explore the fascinating origins of the everyday objects that shape our lives. I'm your host, Kelly. Today, we're looking at something so common we often look right through it. Literally, we're talking about glass. From the windows in our homes to the screens on our phones, it's an indispensable part of modern life. And to help us understand how this incredible material is made, we have a very special guest. David has worked in a glass factory for over 20 years and seen the entire process firsthand thousands of times. David, thank you so much for joining us.
It's my pleasure, Kelly. Happy to be here and talk about something I'm passionate about.
Great. So I want to start with the absolute basics. If I were to try and make glass in my backyard, which I promise I won't, what would I even need? What is glass made of?
Well, it's surprisingly simple, and you're closer than you think. The main ingredient, the one that makes up about 70% of most common glass, is sand.
Just sand, like from the beach?
Essentially, yes. We use a specific type called silica sand, which is very pure. But at its core, glass is melted sand. We mix it with a couple of other things, mainly soda ash and limestone.
Okay, and what do they do?
They're absolutely critical. Think of them as the support team for the sand. The soda ash, or sodium carbonate, is what we call a flux. Sand on its own melts at an incredibly high temperature, over 2,000 degrees Celsius. By adding soda ash, we can lower that melting point to a more manageable, though still incredibly hot, 1500. It makes the whole process economically viable.
So it's a huge energy saver. And the limestone?
The limestone, or calcium carbonate, is a stabilizer. Glass made from only sand and soda ash is actually soluble in water. It would slowly dissolve, not very useful for a window or a drinking glass. The limestone adds calcium oxide to the mix, which makes the final product chemically durable and strong, protecting it from weathering and chemicals. And to that mix, we also add something called cullet, which is just recycled glass.
Oh, so recycling is built right into the process.
Absolutely. Cullet is fantastic. It melts at a lower temperature than the raw sand, so it helps the whole batch melt more evenly and, again, saves energy. We can use a huge amount of it in every new batch.
That's amazing. I had no idea. So you have this mixture of sand, soda ash, limestone, and recycled glass. What happens next? How do you turn that powder into a window?
This is where the magic and the heat comes in. All of those raw materials are mixed together and fed into a massive furnace. And when I say massive, I mean some of these can hold over 1,000 tons of molten glass.
1,000 tons?
Right, and these furnaces run 24 hours a day, 7 days a week, sometimes for years without ever being shut down. Inside, the temperature gets up to around 3,000 degrees Fahrenheit or 1,600 Celsius.
That is unbelievably hot. I can't even imagine what that must feel like to be near.
You feel it from a long way away, I can tell you that. It's like standing next to a volcano. Inside that furnace, the sand and other ingredients melt and fuse together. Over several hours, it transforms into this uniform, thick, glowing liquid that looks like lava or maybe thick honey.
Before we get to shaping it, I have to ask more about the furnace. Maintaining that kind of heat, 3,000 degrees, 24/7 for years on end, that sounds like a monumental engineering challenge. How do you even build something that can contain that?
It truly is. The furnaces are built with special refractory bricks which are designed to withstand extreme prolonged heat. They're very dense and have a high melting point themselves, but even they wear out. The whole furnace is a living, breathing thing. We have a team that monitors it constantly. We control the temperature very precisely with massive natural gas burners. Shutting one down is a huge, expensive deal that's planned years in advance. You have to cool it down slowly over a week, and then the process of chipping out the old solidified glass and rebuilding the brick lining takes months.
And inside that inferno, how do you ensure all the ingredients are mixed perfectly? Is it just a big bubbling soup, or is it more controlled?
That's another great question. The heat itself creates slow, powerful convection currents, like a very slow boil, that helps mix everything. But to get perfectly clear, uniform glass, we have to go through a process called refining or fining. As the raw materials melt, they release gases, creating bubbles. If we didn't do anything, the glass would be full of them. So we add small amounts of refining agents like sodium sulfate. At those high temperatures, these agents decompose and create larger bubbles that sweep up to smaller ones as they rise to the surface, leaving the molten glass perfectly clear. That depends entirely on what you're making. The process for making a flat pane of glass for a window is completely different from making a bottle or a jar.
Okay, let's start with the window. How does that work?
For flat glass, we use something called the float glass process. The molten glass flows out of the furnace in a continuous ribbon, and it floats onto the surface of a bath of molten tin.
Molten tin? Why tin?
Because the glass is lighter than the tin, so it floats on top. And the surface of molten tin is perfectly flat, absolutely flawlessly flat. So the glass spreads out over it, creating a sheet with a uniform thickness and a perfectly smooth surface. No polishing or grinding needed.
That's genius. So it just uses gravity and chemistry to make itself perfectly smooth?
Exactly. It was a revolutionary invention in the 1950s that made modern architecture possible. As that ribbon of glass floats along, it slowly cools down until it's solid enough to be lifted out onto rollers.
Okay, so that's flat glass. What about something more complex, like a bottle? You can't float a bottle into shape.
You're right. For things like bottles and jars, we use molds. A carefully measured gob of molten glass is dropped into a mold. Then, one of two things happens. In the press and blow method, a plunger presses the glass to form the opening and a pre-shape of the bottle. Then, it's moved to a final mold where compressed air is blown in, expanding the glass to fit the final shape.
So it's like blowing up a balloon, but the balloon is made of molten glass.
That's a perfect analogy. The other method is blow and blow, which is similar but uses compressed air for both stages. These machines are incredible to watch. They can produce hundreds of bottles a minute, all identical.
So at this point, you have your finished shape, a window or a bottle. Is that it? Is it done?
Not quite. This is actually one of the most critical steps in the entire process. It's called annealing.
Annealing. What does that mean?
It means we have to cool the glass down very, very slowly in a controlled way. When glass cools, the outside cools faster than the inside. If you let that happen naturally, it creates a huge amount of internal stress in the material.
Right, so it's unstable.
Extremely. A piece of glass that hasn't been annealed is so fragile that even a tiny scratch or a small change in temperature could cause it to shatter into 1,000 pieces. So, the newly formed glass goes through a long oven called a layer. It's very hot at the start and gets progressively cooler along its length.
And this slow cooling process lets the stress even out.
Precisely. It relieves that internal stress, making the glass strong and stable, ready for the real world. I remember one time a new operator accidentally opened a door near the layer, letting in a cool draft. An entire day's worth of production, thousands of jars just cracked and shattered. It was a costly lesson in the importance of annealing.
Wow, it's such a process of extremes, extreme heat, and then extremely controlled cooling.
It really is. It's a material born of fire, but it needs a gentle hand to become strong.
That's beautifully put. Thinking about this whole process, David, it makes you appreciate just how much goes into a simple pane of glass. It's easy to take for granted, but when you stop and think about it, glass has completely changed the world.
Without a doubt, can you imagine a world without it? No windows to let light into our buildings. Think about science. No microscopes, no telescopes, no test tubes or beakers. So much of our scientific understanding is built on our ability to create clear, stable glass.
That's so true. And now we have things like fiberglass for insulation and fiber optic cables that carry the internet around the globe at the speed of light.
Right. A fiber optic cable is an incredibly pure glass thread, thinner than a human hair, and we're sending information through it using light. It's all the same basic principle as the first person who ever melted sand over a fire thousands of years ago. We've just gotten very, very good at it.
From a simple observation to a globe-spanning communications network, That's an incredible journey. David, this has been so incredibly insightful. Thank you for taking us behind the curtain and showing us how this amazing material is made.
The pleasure was all mine, Kelly. I hope your listeners will look at the glass around them a little differently now.
I am certain they will. A big thank you again to our guest, David, and thank you to all of you for listening to Creations of Our World. Join us next time when we'll be exploring the surprisingly complex world of concrete. Until then, stay curious.